Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run optimal binning in SPSS. Optimal binning in SPSS is a technique used to divide a continuous variable into discrete intervals or bins in a way that maximizes the predictive power of the variable for a target outcome, such as binary classification or a regression problem. Optimal binning purpose is to create bins, that is intervals, for continuous variables. Remember, for continuous variable, so that they best predict a target variable. This is especially useful for logistic regression and decision trees. SPSS uses algorithms to determine the best way to split a continuous variable into bins. These algorithms often aim to maximize the difference in the target variable's distribution across the bins. Let's try to understand this concept in the dataset. So here we are having a data. Our target variable, the dependent variable, is that our customer previously defaulted yes or no. The independent variable is age in years, level of education, years with current employer, years at current address, household income in thousands, debt to income ratios, credit card debt in thousands, other debt in thousands. Now we want to see that based on the target variable, that is the customer previously defaulted or not, is there any significant difference in the profile of the customer according to the age in years? That is the age significantly different in those customers who defaulted and those who did not defaulted? So we want to create the bins. At present, age is continuous. So what it will do, it will split the data, or it will optimize the output based on the customer's default. So the age will be divided into two bins based on the customer defaulted or not defaulted. So the continuous data will be converted into categorical. Similarly, this will be done for all other variables also. Okay, now how we can do this? So we will go and transform, and here is it, optimal binning, and transfer all the independent variables in variables to bin. Based on this is to be optimized based on what? So the target variable is previously defaulted or not. So transfer it here, click on output, descriptive statistics, model entropy for variables, and click OK. Done. So we are having descriptive statistics, model entropy, binning summary, that is age in years, level of education, years with current employer, years at current address, household income in thousands, debt to income ratios, credit card debt in thousands, other debt in thousands. So you can see for each continuous variable, the bins have been created: 1, 2, 3, 4, in some cases 5 bins, and in some cases 2 bins. So we will write the interpretation from the model entropy. I'll just simply copy this, right click, copy, and we'll write the interpretation. So the variable, it's model entropy. Lower entropy values are indicative of the variables that are better at predicting the likelihood of default. Just find out which variable is having the lower entropy value. So it is debt to income ratios, and the second one is years with current employer. So these are the best variables for predicting the likelihood of the default. The entropy values indicate that the debt to income ratio, followed closely by years with the current employer, are the most effective predictors of default among the variables listed. Variables such as age here, education level here, and household income have a higher entropy values, meaning they are less effective in predicting default compared to the debt to income ratio. Next is age in years. So the first bin up to the age 32, and the second bin all those customers which are having age more than 32. Now in the first bin, total customers are 1768, out of which those who did not defaulted are 1129, and those who defaulted are 639. In second bin, the total customers are 3232, those who did not defaulted 2615, and those who defaulted 617. So the binning summary divides a continuous variable age in years into two distinct bins to analyze its relationship with the target variable previously defaulted. The summary for age in years shows that 1768 customers, all aged 32 years or younger, are put in bin 1, while the remaining 3232 customers, this one, all greater than 32 years of age, are put in bin 2. The proportion of customers who previously defaulted is much higher in bin 1. So how we calculated it? 639 divided by 1768. So this number, this percentage is 0.361. And in bin 2, we are having 617 divided by 3232. So it is 0.191. 0.191. So we can say that the age is an important factor in deciding that a person will default or not default. So if the customer is having having the age less than 32, the likelihood of defaulting is more. Next is years with current employer. This we got it from here. So here we are having 4 bins. So bin 1, 2, 3, 4. We will calculate the proportion of defaulters in each bin. So how we will calculate? 478 divided by 1107. So we got 0.432. 461 divided by 1527, 0.302. 268 divided by 1739, 0.154. 49 divided by 627, 0.078. So there is some observation. As the years with current employer increases, the likelihood of defaulting decreases. So the summary for years with the current employer shows a pattern of decreasing proportion of defaulter as the bin number increases. This is the bin number. So this is a good sign. So when we are giving loan to any customer, so there are factors which we can consider is that is the age, years with current employer. So these are the factors on which we will be able to decide the likelihood that the customer will default or not default. The next is household income in thousands. So the bin 1 up to 26.70 and the second bin is more than 26.70. So 513 cases are there in the first bin, 743 cases are in the second bin. The summary for household income in thousands shows a similar pattern with a single cut point at 26.7 and a higher proportion of customers who previously defaulted in bin 1. So 513 divided by 1567 is 0.327 and then in bin 2, 743 divided by 3433 is 0.216. As expected from the model entropy statistics, the difference in this proportion is not as great as that for age in years. So you can see that difference is not so large. In case of years at current employer, the difference was very large. See, similarly, age in years, the difference was large, 0.361 and 0.191. In this case, the difference is not so large. Other debt in thousands, debt up to 2.19, 539 cases, more than 2.19, 717 cases. So the summary for other debt in thousands shows a reverse pattern with a single cut point at 2.19 and a lower proportion of customers who previously defaulted in bin 1 than in bin 2. So this is 539 divided by 2700 is 0.2. Then in bin 2, 717 divided by 2300 is 0.312. Naturally, why this happened? Why the reversal happened? Because as the debt increases, okay, the possibility of the default increases. Again, as expected from the model entropy statistics, the difference in this proportion is not as great as that for age in years. The difference is very less. See, this is 0.2. The proportion of the defaulters in the bin 1 is 0.2 and in bin 2 0.312. So it's not large. So this was all about optimal binning in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.